I'm here to present a small project that was done in the, let's say, open source community. It started last year at the biohackathon with people. So I will present how we could create SPARQL query endpoints from the InterMine database. The InterMine, first I will talk about the InterMine and semantic web, very short 101 thing. Then I will explain how we can do this data transformation from existing REST services to a SPARQL endpoint. Just so for those of you who have no idea what a SPARQL endpoint, it's a knowledge graph technology coming from 20 years old web semantic approach. So then I will show what's the results of an InterMine SPARQL endpoints. So InterMine is a 20 years old project. It's a data model. It's based on data model of sequence. It's a Java application used by all the major model organism database. It has a very simple to use user-friendly web interface. It was designed to integrate the data. So you can imagine Overture, for example, is a way to build new application. InterMine was a way to do it 20 years ago. There is more than 20, there's almost 20 different InterMine database. So here's a look at what building a query is within InterMine. You have a query generator, and you can run this query and get the answer. In this case, is what pathway is a specific genes involved in. We will come back to this query later. InterMine was designed with the API approach. So there is an automatic generator of code for many languages. Here's an example in Python. So you can build a query and then run this query within your preferred language. Now, semantic web. It's an old idea. It's an idea of doing high-quality data for data interoperability. 20 years ago, it started, and it was called semantic web. It's not that much popular anymore. It's based on RDF. RDF is a way to represent all the data with triples. And we put triples into triple store, database for triple. And this special graph database can be interrogated with SPARQL, which is the query language of triple store. So for those of you who have used Triple Store before, Virtual was very popular as a database to do semantic web application. So here's 20 years of evolution. 20 years ago, I was here trying to find a subject. I created Bio to RDF. It evolved for almost 10 years, where it was a kind of very popular data integration approach based on semantic web for the life science. Down on the slide, you see how the database, each dot you see is a SPARQL endpoint. So from very few of them, now there is hundreds of them which are available. And here's an example of actual SPARQL endpoints you can use if you get interested in. Uniprot is a major one. PDB is one hosted in Japan. KEG has its own. The Wikidata, which is a conversion of Wikimedia knowledge base into a graph as SPARQL. But InterMine's not there. And it's an old problem. Michel Dumontier, who have been involved with Semantic Web 2, created a project a few years ago, but it's not online anymore. So we had the project last year at the biohackathon in Japan to do it again. And now there's a very nice new technology that simplify a lot transformation from existing data to RDF. So this is what we are using. We use LinkML to get the model of link of the InterMine database. You have to know that InterMine, for example, for each instance, you have more than 200 tables. So once we have done the conversion, it's loaded into a new triple star named QLever, which is very, very performing. So we did that for 3 model organism database. And here's the final results where we can replace the old the approach with the new one, doing a SPARQL query over InterMine. And of course, we get the same answer, which is, of course, the proof that the conversion worked. So now there is all kinds of new technologies since the last 10 years that simplify the conversion of existing API to RDF, so we can create a new knowledge graph using semantic web technology. And in the future, we will add other InterMine. And I invite you to try to generate SPARQL query with your LLM of choice, they all know how to write SPARQL query. And it's very interesting, and this is where we would go to. Thanks for my collaborator, and especially the biohackathon and the BOSC of this year. I wouldn't be here if I was not funded for that. Thank you very much.